In this video, we look at the number system. Now, there is not only one type of number system, but the number system that we work with at school level is the real number system. Now, this is something that you are familiar with, but what is a number system? It's a way of classifying numbers, and a number system divides numbers into different groups or sets of numbers. And this number system becomes increasingly important in our understanding of maths because different contexts require certain types of numbers. So consider the situation where you are counting people. What types of numbers would you use? You can't have half a person or 2/3 of a person. So the numbers that we use are 1, 2, 3, 4. We can even have no people, so 0. What set of numbers is that? Or we could have prices, okay? So if we consider how things are priced, we recognize 9 Rand 99 cents, okay? That's a decimal up to 2 decimal places. Now that's the norm of how we price things. We wouldn't go into a shop and really see 2.5 Rand like that, okay? So in the context of price, we use decimals. So similarly, there are many different contexts that arise in real life that require certain types of numbers. And that is a basic importance of the different sets of the number system. Okay, before we get to the number system, just a quick revision of the number line. Okay, now when you started school, you started counting 1, 2, 3. What did you count? You counted your fingers, you counted candles on a cake. They were objects. Okay, and as you progress through your maths, we then count numbers on a number line. Okay, now how does that work? We start with 0, and then if we have this equal spacing, we know that we are progressing with full numbers, the whole numbers. Okay, so 0, 1, 2, 3, 4. Then if we look at the opposites, okay, we have -1, -2. So -1 is opposite 1 across the 0, if you like to think of it like that. Okay, now these already here, I've got 3 sets of numbers represented. Okay, do you remember what they are? But nonetheless, looking at the number line, the number line helps us to position numbers. So if we know a number's value, we know where on the number line it sits. And that is very important. So if I have the number 1.5, 1,5, where does it sit? I know it sits halfway between 1 and 2. Okay, if I have the number 2,99999, so 9 recurring, where does it sit? It's more than 2 but less than 3, so it sits just before the 3, 2,9999, and so on. Okay, so the number line is very important, and we see this number line in various contexts, like when we deal with functions, for example. Okay, and it will become important in trigonometry and calculus, so it is very important that you do understand the number line and the number system. Right, let's recap the number system. Now, the number system that we study at school is called the real number system. Now, within the real numbers, there are different groups of numbers. Okay, so let's start with the smallest group, and those are what we call the natural numbers. And we know them as our counting numbers. Those are the numbers 1, 2, 3, 4 that we start with in grade 1, or even before grade 1. Okay, the next set is the whole numbers. These are the counting numbers and 0. So 0, 1, 2, 3, and so forth. Okay. Now the way this diagram works is each square represents a set of numbers. And if the set is within another set, so if the natural numbers are in the set of whole numbers, that means that they are included. So natural numbers are automatically also whole numbers. Okay. But not all whole numbers are natural numbers. Right, going on to integers, those are the counting numbers, so 1, 2, 3, and their opposites, -1, -2, -3, and 0, okay? And then we have rational numbers, so rational numbers are any number that can be written as a fraction. So if we take the number 4, for example, 4 can be written as 4 over 1. If I take the decimal 0,6 recurring, that can be written as a fraction as 2 over 3. Okay, I can also take the decimal 0,729 and write that as a fraction as 729 over 1,000. Okay, so any number that can be written as a fraction is a rational number, and specifically decimal numbers that are rational will be repeating decimals. So for example, the 0,6 recurring, that's 6 repeats, 0,66666, it repeats infinitely. Or we can have terminating decimals, like the 0,729, it ends. Right. Then we have irrational numbers that are also part of the real number system. So irrational numbers are basically not rational numbers, okay? And they are a real number that cannot be written as a fraction. Okay, so the way this looks like in decimal form is that we have non-repeating, non-terminating decimals, okay? And where we see irrational numbers typically is also in what we call surd form, okay? So surd form is when we have a square root of a non-perfect square or a cube root of a non-perfect cube. So let's say the cube root of 5, for example, okay? And then pi, okay? Now, when you are wanting to check whether a number is irrational or rational, that is a good way to check. So if you have a square root, check, is your number under the square root a perfect square? No, then it's irrational, okay? Or you could convert them to, use your calculator to convert them to a decimal, and root 2 would equal 1,421421356 for example, but your calculator's screen is limited. So this number actually carries on, but on your calculator it'll terminate at 2. So you just have to be careful, okay? But if we look in this decimal, nothing is recurring, okay? But we know for sure that it is also not ending, non-terminating, because 2 is not a perfect square. Right. That is the real number system. Now, real numbers are any number that can be positioned on the number line. So if we can find its position on the number line, it's a real number, okay? So I've worked from the bottom up. I'm just going to work from the top down. So real numbers can be divided into rational or irrational. Rational numbers will be integers, whole numbers, or natural numbers. And on the next slide, we'll focus on the fractions, okay? There are, however, also numbers that are non-real, okay? And these, for example, would be the square root of a negative number. Now, that number exists. It is used in mathematics, and it is actually a very useful number, but it's not used at school level. But nonetheless, these numbers exist, even though they are called imaginary numbers. We don't understand its value as such, so we can't place it on the number line. We don't know where it would fit. But to recognize a non-real number at your level, it would be the square root of a negative number. Okay, and then I just want to address one more thing, and that is undefined. The concept of undefined. If a number is divided by 0, so 2 divided by 0, we say that that is undefined. So anything divided by 0 is undefined. It's not a real number. It's not even a non-real number. It's on a category of its own. It's not part of the number system. It doesn't exist. It's simply undefined. Okay, right. Just a quick different view of the number system. And here what I'm going to put in is the notation we use for the different sets. So we have real numbers and non-real numbers. Real numbers are represented by an R with 2 lines like that. Non-real numbers are the R with a little apostrophe that represents not in maths. Okay, so real is the R, non-real is the R not. So not real. Then we have real numbers are divided into rational numbers and irrational numbers, and rational numbers are represented by the symbol Q with an extra line. Irrational numbers are not rational, so we represent them with a Q not. Okay? Then rational numbers are divided into integers or fractions. Fractions doesn't have a special symbol, but integers are represented by a Z with an extra line. Then within the set of integers, we have whole numbers, which are represented with the N and the little 0. And within whole numbers, we have natural numbers, which are represented by the N and without the 0. Okay? It is very important that you know these symbols and are able to use them and recognize them. You will be tested on them, so please learn them. Then we just do a quick recap. Fractions can be your common fractions or your decimals, and then our common fractions can be proper fractions that have a larger denominator, or improper fractions which have a larger numerator, or mixed fractions which have a whole number and then a fraction. The decimals will be finite, so they end, so 0,15 for example, or recurring, 0,15 recurring. Okay. Right, then our irrational numbers can either be non-recurring, non-terminating decimals, so 0,1237986 well, that's not a 4, that's a 2, 4, and so forth. There's no pattern, and it doesn't end. And then we have surds. These are our square root of a non-perfect square, or a cube root of a non-perfect cube, or a fourth root of a non-perfect fourth, for example, and so forth. Okay. Right. Now, you must understand the number system and must be able to classify them. And also, when we deal with a different context, you must be able to understand the terminology and the symbols that we use in mathematics. Now, what you will often see is something like this. X is an element of, and then one of those sets will be written down. So what this reads as X is an element of, Z represents integers. What this means is that the numbers that you are dealing with can only be an integer, okay? So, remember that X represents a variable. Now, what is a variable other than a letter in maths? It's a measurement that can vary, okay? So, what measurements in real life can vary? Let me just finish writing this. Okay, think of measuring temperature, okay? If we talk about the temperature, it can be very cold at negative 12 degrees Celsius, okay? Water can freeze at 0 degrees Celsius, or we can have a very hot day at 32 degrees Celsius, okay? Temperature can be measured in decimal form, but we commonly experience temperature as measured like with these numbers. Okay, now what set of numbers are we dealing with? These are integers. Okay, so in the context of temperature, we commonly work with integers. Okay, and finally, you must be able to classify numbers. Okay, so let's do an example. You have done this before, but let's work through 3 examples. So, you first of all must recognize these symbols, okay? R naught is not real. R is real numbers. Q is rational. Q naught is irrational. Z is integers. N with the 0 are whole numbers, and N are natural numbers. Now, if we consider the number negative 19, okay, so first of all, negative 19, is it real or non-real? Okay, we can place it on the number line, so it is real. Is it rational or irrational? So ask yourself, can it be written as a fraction? Yes, it can be written as negative 19 over 1, so it is rational. Okay, and these are mutually exclusive, so you can't have a number be real and not real. Only one of them will apply. You can't have a number be rational and irrational. Only one of those can apply. Okay? But a number can be an integer and a whole number and a natural number. But negative 19, that is an integer, but it's not a whole number which only starts at 0, and it's not a natural number which only starts at 1. If we look at the square root of 40, okay, is it real or non-real? Square root of 40, 40 is a positive number, so it's not non-real, it's real. We can actually find its value. If you were to put it on your calculator, you would be able to say which integers it lies between. Okay, so square root of 40 comes to 6,324555532 and so forth. But 6,3 and so forth, we know it would lie between 6 and 7. We can place it on the number line so it's real. Now you have to decide, is it a rational number or irrational? Can I write it as a fraction? Okay, not so clear. Let's think of the decimal form. It is a non-terminating, non-recurring decimal that places it as an irrational number. Okay, but even easier than that, the square root of 40. 40 is not a perfect square. The square root of a non-perfect square is irrational. Right, and if it's irrational, it cannot be an integer, a whole number, or a natural number. Looking at the last number, 7 over 4, is that real or non-real? It's definitely real. We can place it on the number line. Is it rational or irrational? It's written as a fraction, so it's definitely rational. Is it an integer? No. Is it a whole number? No. Is it a natural number? No. So we are done with the classification.